The findings of recent global assessment show that areas of the oceans are warming much more rapidly than expected.
As we're going to Copenhagen and looking into the whole Convention on Climate Change, we notice that there's very little talk about the role of the oceans overall. And in fact, the oceans probably have a greater role in terms of modifying the climate system than, for example, forests have. So we're, I think, in many ways missing a very important ingredient in terms of the natural ecosystems and how they affect the planet and its climate.
We're collecting an enormous amount of scientific data, both on land, coastally and offshore, using various research vessels that we have within the region. A lot of the data we're collecting is absolutely brand new. We are very much in a mare incognitum, or an unknown sea. So everything we're picking up data-wise is really very cutting edge and brand new for the whole Western Indian Ocean, because not that much research has been done there. Translating that science into good guidelines for policy and management is an enormous challenge. Scientists obviously have their own way of presenting data. They require and demand very high levels of confidence in data before they can actually make any kind of predictions. But in this modern day, when we're confronted by rapid change from climate and rapid changes and variability within ecosystems, we don't have the luxury to wait until we're absolutely 100% sure. So what we used to call the precautionary approach, we're now calling the need to act on weight of evidence.
One aspect that we have been missing is the fact that the oceans absorb a very large amount of the carbon that we've been burning. So they're very important for carbon capture and storage. At this stage, we have that happen in two main ways. The first one being CO2, and carbon dioxide, being dissolved in water. So basically, you're turning the oceans into fizzy water. So we've already seen 30% more acidity in the ocean than what we used to. So it's already 30% more acid than what it used to be. So that's quite a dramatic shift in a relatively short period of time. At the same time, we're also seeing the productivity of the system going down.
Now, with this information in hand, we have the possibilities for adapting to these changes with regard to world markets for fisheries, with regard to strategies for developing means to overcome the degradation. In view of the rapid warming, we've got to get busy and alter the situation and mitigate to the extent that we can and adapt.
What we really need to do now is to develop a very specialized skill set within our scientists and within our policymakers, whereby we can actually translate the science that we're collecting on a regular basis into predictive modeling and effective guidelines for good policy, so that we can take that science to the policymakers and say, look, we may not have all the facts here, but we're pretty sure that we know what is happening. This is where you need to prioritize your resources if you're going to adapt over the coming decades to climate change and to ecosystem variability. Vice versa, we need the policymakers to be able to tell the scientists what their priorities are as far as the social implications, as far as the economics are concerned, so that there is a to and fro here. There is a compromise between science and policy and good governance that arrives at an effective management approach. That is our other big challenge, and the one that we really are embracing, translating the science into policy guidelines that can be acted on quickly and effectively.
And in some cases, that means socioeconomic activities like fisheries will be affected. In some areas, that will be a positive thing, because the warming will enhance the production of plankton, and that in turn will increase the annual productivity of the fish stocks. So in some areas of the world, especially around the subarctic regions like the Gulf of Alaska or the Norwegian Sea, one could expect significant increases in fisheries and fish populations, whereas in places like Australia or the tropical parts of the globe, we would experience lower productivity because of the effects that global warming will have on the surface layer making it much warmer than the subsurface layer, and that is a physical feature that would cause a discontinuity between the warm water and the cold water, and that would make it much more difficult for the nutrients to mix through the water column to increase productivity. So in effect, large parts of the globe will be experiencing declining productivity.
So a lot of people are still wondering, is climate change really happening? To them I would say, when we're in the ocean, we can already see some very major shifts. For example, coral reefs have now been dying across the globe at alarming rates. Part of the Indian Ocean, for example, lost almost half of its coral reef at a bleaching event in 1998. So these are cataclysmic events. We have coral heads that are 1,000 years old, so we know this hasn't happened in 1,000 years. That's a pretty clear indication that something is adrift here that wasn't happening in the past. We can also look at sea ice in the Arctic. We've already lost about 40% of the sea ice in terms of thickness. We're also on a very clear trajectory of having ice-free areas, so we will be able to start commercial shipping through the Arctic now in a matter of years. Now, this is a very dramatic shift that sort of happened while we were responsible, and we have to ask ourselves, what are the long-term consequences of that? How do we manage in this new environment, and how can we make sure that future generations have a healthy environment to live in?